understand distance and midpoint. So we're going to start with that. By the way, I'm doing this in OneNote, the same OneNote program that we use in class for our notes. So you can find these notes from the link in your D2L classroom. So we're going to start with the idea of how to find the distance between any two random points on a graph. So for example, let's say I have a point in the XY coordinate system, one here and one here, and I want to find the distance between the 2 points. Okay, so the length of the line segment that would join the 2 points, in other words. So one way we can do this is, since the XY coordinate system is set up as a grid, we can imagine dropping a line down from the top point. Let me see. Here we go. And a line across horizontally, forming a right angle, and we have a right triangle. And pretty much everybody, for some reason, is able to remember pretty easily the Pythagorean Theorem, I guess because we start so young with it. So if you call this side A, this side B, and this side C, remember that A squared plus B squared equals C squared. So if you know the coordinates of these 2 points, let's say this is x2, y2, and this is x1, y1. Those are not powers, those are subscripts. These are just a way of saying point 1 and point 2. If you know the coordinates of the points, you can find these distances A and B, and then you can use the Pythagorean theorem to find C. So for example here, A is going to be the vertical distance between y2 and y1, which you can get by just subtracting the bigger y value minus the smaller one, or the smaller minus the bigger and just using the positive version, the absolute value. And then for B, it's the horizontal distance between these two x values, so it's x2 minus x1. And then C is the distance, which I'm going to call D, which we're looking for between the 2 points. So instead of, I'm going to move this C squared over here, by the way. Instead of C squared equals A squared plus B squared, we can think of this as D squared equals, instead of A, we have y2 minus y1 being squared, plus, instead of B, we have x2 minus x1 being squared. Or in other words, and I prefer to put the x's before the y's, so I'm going to just use the commutative property of addition to rearrange this a little bit. In other words, d squared is x2 minus x1 squared plus y2 minus y1 squared. And we don't want the distance squared, we want the actual distance. So we could use the square root property to see that the distance, and I'm going to move this down a little bit. Oh, I don't really need to remember the plus or minus in this case. So what we have here is called the distance formula. It's the distance between 2 points, x1, y1, and x2, y2. So all you need to do, I'm not going to expect you to develop the formula like we just did, but I do need you to be able to remember the formula and apply it. So, for example, I might ask you to find the distance between the point 4, -1, and -6, 3. And one thing I want you to pay attention to when you're doing your homework is that you will be asked to give both exact answers and rounded off answers. So the exact answer, I'm going to say express in simplified radical form. So what that means is that the answer might not turn out to be an integer. It might have a square root in it, and you want to simplify as much as possible, but if you can't simplify it all the way, you still need to make sure to take out any perfect square factors. And then let's also round off to 2 decimal places. Okay, so the simplified radical form is the exact version of the solution. Your exact answer is the radical. And when you round to 2 decimal places, this is really an approximation, because there are a lot of numbers you can't represent as a terminating decimal. All right, so in this case, what we want to do is plug into our distance formula. D equals the square root x2 minus x1 squared plus y2 minus y1 squared. We just have to decide which point we're going to let be our x1, y1, and which will be our x2, y2. It doesn't matter. It'll turn out the same either way. So let's say this is x1, y1, and this guy is x2, y2. And that's coming out kind of sloppy. Let me zoom in maybe a little bit. I'll just make it bigger. Let's see. So this will be our x1. Y1, and this will be our x2, y2. Okay, so plugging into the formula then, we have the distance is equal to the square root, and then we have x2 minus x1, so that's going to be -6 minus 4 squared, plus y2 minus y1, so 3 minus -1. And I purposely picked 2 points that have negative coordinates because I want you to make sure and pay attention that you don't make sign errors. All right, so we have distance equals -6 minus 4 is -10. So we have -10 squared plus 3 minus -1 is 3 plus 1, or 4 squared. So the distance is going to be equal to the square root of, and then we have 100 plus 16. So the distance is the square root of 116. Okay, now 116, so this is the distance, okay, but it's just not in a format that we necessarily like. We need to get it in simplified radical form. If this number is not a perfect square, we want to see if any of its factors are a perfect square. The way that I prefer to do it is to look at the prime factorization. You might just divide out perfect squares, which is fine also. But I like to start with the lowest prime number 2 and divide in as many times as I can. So for example, 2 goes into 116 58 times. 2 goes into 58 29 times, and then 29 is a prime. So we're going to say that this is the square root of 2 squared. We have 2 factors of 2 times 29. Now the square root of 2 squared is just 2, so we have 2 square roots 29. So how's everybody doing so far? Remember, if you have any questions, you can always type them into the chat bar. Sometimes my chat bar doesn't want to work for some reason. Let's see. I hate it when this happens. Okay, let's leave it for a minute. All right, so this is the exact solution, 2 square roots of 29, and we also want an approximation, so I'm going to open up my calculator here. So I'm going to take the square root of 29, And I'm going to multiply that by 2. Or you can just take the square root of 116. Doesn't matter. And we're going to get 10.77. Now, if you think about it, 10 squared would be 100. It makes sense the square root of 116 would be bigger than 10, square root of 100. And 11 squared is 121, so it makes sense that the square root of 116 would be a little less than 11. So it's reasonable that our approximation would be, we have that this is approximately 10.77. Okay, so what did we just find? Remember, we just found the distance in the xy coordinate system between a point 4, -1. Uh-oh. Oh, I lost you for a moment. Hold on. So we just found the distance between 4, -1 and -6, 3 in two different ways. The exact distance, 2 times the square root of 29, and the approximate distance, 10.77. Okay, so why are we interested in, oh, well, and one more thing, we need to find the midpoint also. We need to learn how to find the midpoint between 2 points in the xy coordinate system. So let's go ahead and draw a picture of these 2 points that we just analyzed the distance between, 4, -1 and -6, 3. Oh, let's see, actually. Okay, so 4, -1, 1, 2, 3, 4, -1 would be about here. And then the other point, oops, was -6, 3. Okay, we just found that the distance between those 2 points turned out to be a little more than 10. Okay, and now what I'm wondering is not the length of the line segment, but what point would be exactly in the middle of the line segment? We're looking for a midpoint. So it looks like it would be about here, right? But what would be the exact coordinates of that point? So one way to think about it is we would be horizontally halfway between -6 and +4. And vertically, we would be halfway between -1 and 3. And so we can find the x and the y coordinates for that midpoint separately by averaging the x coordinates and averaging the y coordinates, finding their mean. So how do you find the average of two numbers? You just add them up and you divide by 2, right? So for example, if I wanted to find what's halfway between the x values -6 and 4, all you do is you add -6 and 4 and you divide by 2. Going to be -2/2, which is -1. So, and doesn't that look like it's halfway? Let's look. Here's on the, and we're talking about the x values now, so the horizontal difference here between -6 and 4. And if you go to -1 on the x-axis, look, that's 5 units away from -6, and it's also 5 units away from 4, so it's halfway in between. All right, so what we just found is that the x coordinate of the midpoint is going to be -1. Now let's find what's halfway between the y values -1 and 3. So what's halfway between -1 and 3? So you average them. -1 plus 3 over 2. That's going to be 2 over 2, which is 1. So the y coordinate turned out to be 1. So -1, 1 would be right here, which is right where we thought the midpoint of the line segment should coordinate separately. The x coordinate is going to be the average of x1 and x2. So x1 plus x2 over 2. And the y coordinate is going to be y1 plus y2 over 2. All right, so we've learned so far the distance formula, d equals the square root x2 minus x1 squared plus y2 minus y1 squared. And now the midpoint formula, where you find the average of the x coordinates and the average of the y coordinates, and those give you your new x and y coordinate for the midpoint. Now the reason we wanted to look at these topics is because we're going to be talking about circles. And circles involve distances and midpoints in some cases. So what is the definition of a circle? By the way, I hope you are looking at your textbook. Remember, we do have one, even though it's an ebook. And if you look at page 327, you're going to see the definition of a circle. And it says that a circle is the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle's center to any point on the circle is called the radius. Okay, so I wanted to show you this formal definition of a circle so you can see how it involves distance. But let's think about what a circle is. Okay, a circle revolves around one point called the center. And of course, it's hard to draw it freehand. Let me cheat a little bit here. All right, so here's a circle. Oops. It looks a little bit more like an ellipse. Let's make it more round. Okay. What every point on the circle has in common is that it's the same distance from the center. That distance is called the radius, so we often denote it with an r. And the center we denote with h, k. So if we wanted to be able to write an equation relating any random point on the circle xy to the radius and the center, we could use the distance formula. So remember, the distance formula says that the distance between any 2 points, x1, y1, x2, y2, is x2 square root of x2 minus x1 squared plus y2 minus y1 squared. And what we have here is 2 points. So what we're going to do is we're going to think of hk as our x1, y1. And we're going to think of this guy here as our x2, y2. And r is the distance between them. So we can plug into this formula here, and we're going to have r equals the square root of, and then we're going to have x, instead of x2, we have just x, minus x1 is h, squared, plus y2 minus y1 is going to be y minus k squared. And so a formula, and we don't like leaving the square root because it only represents sort of half the circle where we have positive. So what we're going to do is we're going to square both sides, and we get x minus h squared plus y minus k squared equals r squared. And this we call the center radius form of the circle. Sorry, we're having trouble. We're jumping in and out of streaming. Apologize if you're experiencing some jumpiness. Okay, so we're going to, I don't think there's anything I can do at my end. I'm not sure why it's happening. Let me see. So I'm just trying to check on my streaming here. Hold on just a minute. Okay, we're back to good now for some reason. All right, well, that's good news. Hopefully it sticks around. All right, so just like with the distance formula, I need you to memorize the center radius form of a circle. Understand the relationship between the center radius form and the distance formula. It's a little bit easier to memorize, but I'm not going to ask you to develop it or anything like that. So what we're going to do next is just apply this formula, the center radius form of a circle. And what I mean by that is if I give you a circle, an equation of a circle in center radius form, I just need you to be able to identify the center and graph the circle. Okay, so given the equation of a circle in center radius form, identify the center and radius and graph the circle. And we'll start with the equation x minus 2 squared plus y minus 1 squared equals 9. Okay, so when you're doing this, you want to compare this to the formula that we just learned. So I'm going to write it down right below it. X minus h squared plus y minus k squared equals r squared. And remember, hk is the center and r is the radius. Okay, so let's start by identifying the radius. So since this is a circle in center radius form, in other words, because it fits the pattern here, we know that it's a circle. And on the end here, this number 9 is r squared. So if we're looking for the radius, we need to use, hold on one second. Okay, sorry about that. So now we want to say, well, if r squared is 9, that must mean that r is plus or minus the square root of 9, but a radius is always positive. So we're going to just have the positive square root of 9, which is 3. Okay, so the way we find the radius when we have an equation in this form is we just take the square root of that number on the right. All right, so our radius is 3, and our center is going to be hk. Now, h is the number that's being subtracted from the x. So in this case, 2 is being subtracted from the x, so the center is 2, or the x-coordinate of the center is 2. And k is the number that's being subtracted from the y, so in this case, that would be a 1. So we have the center 2, 1. All right, now that we have the center and the radius, that's enough information to graph the circle. So let's pull up some graphing paper here. All right, so if I want to graph this circle, I'm going to start by plotting my center. Okay, let's move this down. So again, my center was 2, 1, and my radius was 3. So I'm going to go to the point 2, 1 on my graph. Ooh, let me move this. It's a little off. Okay, I think that's better. Okay, so I'm going to go to my center at 2, 1. I like to put an X instead of a dot when I plot the center of a circle, just to emphasize this is not actually a point on the circle, but just a reference point. So there's 2, 1. And then we're going to have a radius of 3, which means every single point on the circle is going to be exactly 3 units away from the center. Now, it's hard to find that distance off to the diagonal, but if we go straight up, straight down, straight to the left, and straight to the right, we can find exactly the coordinates that are 3 units away. I call them the north, south, east, and west points, right? So these are the points I will always want you to graph on your circle. 1, 2, 3 units up, you add 3 to the y value, and that's going to be the point 2, 4, right? Adding 3 to the y. To get that's the north point. The south point is going to be 3 units down. So subtracting from the y, 3, we would have -2. So we're going to be down at 2, -2. Okay, so there's the south point. East and west. So if we're going to go to the east, we're adding 3 to the x this time. 3 units over from 2 is going to be 5, 1. And to the west, we need to subtract 3 from the x. 2 minus 3 is -1. So we'll be at -1, 1. And then we can draw in our circle. Okay. Try to get it lined up as best we can here. Don't want to lasso. Stop. It's going crazy. Ah. What on earth? I'm not doing this, folks, I promise. Hold on. Weird. Okay, so the streaming died for a minute, and I'm not sure what all you saw there. But hopefully you can see this circle with the north, south, east, and west points plotted. Again, how do we get those points? From the center, we need to go over 3 units because the radius was 3. That's too tiny. Can't read that. Okay, we had a radius of 3, so you're going to go up 3, to the left 3, to the right 3, and down 3 to get your 4 points. All right, now, one thing that's tricky with this formula is that the center coordinates are being subtracted from the x and the y. So in this particular example that we just graphed, x minus 2 plus y minus 1 squared, x minus 2 squared plus y minus 1 squared equals 9, it wasn't so tricky to find h and k because those numbers were both being subtracted. But sometimes you'll have an addition symbol for one or both of those center coordinates. So let's see what we do in that case. Okay, so let's say that I wanted to graph the equation x plus 3 squared plus y minus 2 squared equals 16. Okay, so you can tell by the pattern that it fits that this is going to be the graph of a circle. It matches up with x minus h squared plus y minus k squared equals r squared. We can find the radius very quickly. We know that r squared is 16. Oh, we just went dark again. Oh, we're back. Okay, so we know that r squared equals 16. That means that r is equal to 4. So our radius is 4. But the tricky part is identifying h and k. So what's happening here is that h is the number that we're subtracting from x. So you might think that you have to write a 3, but 3 is not being subtracted from x. Remember that adding 3 to x is the same as subtracting negative 3. So it's not actually 3 that's our x coordinate of our center, it's negative 3. So in other words, look for the opposite of the sign you have here. Now with the k, that's a little easier because we're looking for what's being subtracted from y, and this one has a negative, so it's just a 2. So just think opposite. So sorry, it keeps cutting out. Okay, so we found our radius was 4 because we had a 16. Square root of 16 is 4. We found that our center was negative 3, 2. So now I'm going to actually plot this. So going out to negative 3 and up to 2, we have our center, negative 3, 2. Be sure and label your points on your graph. And then we're going to go up 4, down 4, to the right 4, and left 4. So remember, all that comes down to is adding and subtracting 4 to each of the x and y coordinates individually. So what I mean by that is to go up, you add 4 to the y coordinate, so that's going to be negative 3, 6. Okay, to go down, you subtract 4 from the y coordinate, so that's going to be negative 3, negative 2. To go to the left, you're going to subtract 4 from the x coordinate. That's going to be negative 3, negative 7. I'm sorry, negative 7, 2. Subtracting 4 from negative 3 gives you negative 7. The y coordinate stays the same. And, oops, I drew that up a little too high. Let's fix that. There we go. And then to get the point to the right, we're going to go add 4 to the x-coordinate. So negative 3 plus 4 is going to be 1, and the y-coordinate stays the same. And then we're going to just draw in our circle. Oops. Okay, and so there's our circle. All right, so there's only one more thing we need to learn in this section. And by the way, this is section 2.8 for my students in their textbook, section 2.8. So on your test, we're going to do sections 1.2, 1.5, 1.6, 1.7, and then we're going to jump to chapter 2, section 8 and do circles. Okay, so we've learned distance and midpoint. We've learned center, radius, form of a circle. And then the last thing we need to talk about is, oh, and by the way, we're not going to work a problem like this, but one context regarding circles in which you might need to use the midpoint is, let's say you were given 2 points on the diameter of a circle. By the way, diameter of a circle is twice the radius. It goes all the way across. If I were to ask you for the center of the circle, given that it goes through negative 7, 2 and 1, 2, you could find the midpoint between those points and give me the center. Okay, but what we're going to focus on is the general form of a circle. And so we've been talking about the center radius form, which is a useful form because we can identify the center and the radius. But unfortunately, circles are not always given to us in that format. So let's see what other format circles can take. So one of the circles that we graphed already was x minus 2 squared plus y minus 1 squared equals 9. Let's say that we wanted to see what this equation would have looked like if it was FOILed out. So squaring this binomial x minus 2 quantity squared, let's use that pattern we've been talking about in class. So the first term squared, x squared, square the first, square the last. Negative 2 squared is positive 4. Multiply together gives us negative 2x, and double up fast, we get positive 4x. Plus, over here we have square the first, square the last, multiply together, and double up fast again. So square the first, we get y squared. Square the last, we get positive 1. Multiply together, we get negative y, and double that, we get negative 2y, and equals 9. All right, combining like terms on the left here, we get x squared. And by the way, we like to write it in descending order of the exponents. So I'm going to put x squared and y squared. I'm going to put 4x and negative 2y. And then I'm going to add the 4 and the 1, and that's going to be 5 plus 5 equals 9. And to get it in general form, we're gonna, it's kind of like the standard form of a quadratic, we're gonna get 0 on one side. So I'm gonna subtract this 9. So we're gonna get x squared plus y squared plus 4x minus 2y minus 4 equals 0. All right, so if you got an equation in this format, you would also know that this is going to be the graph of a circle. It has to fit the pattern of x squared plus y squared plus dx plus ey plus f equals 0. In other words, we have any real numbers here. So if we have something that fits this pattern, it also is the equation of a circle. The question is, though, if I give you something in this format, how do you get it back to this center radius format so that you can actually graph the circle? So you can identify the center, identify the radius, and graph the circle. And the answer to that question is completing the square. So remember how we practiced completing the square when we were solving quadratic equations, where I told you that later we're going to have to use completing the square. There won't be any alternative when we're graphing circles. And so we've reached that point. So what we're going to do now is walk through the procedure of going backwards to get from the general form to the center radius form. So let's go ahead and start with this same equation that we know how it's supposed to end up. Let's see how we can reverse our step. And I'm running out of room here. Let's see, radius. Form. Okay, so what you're going to want to do is we want to get to the point where we are back to having the x's and the y's grouped together. So the first thing you're going to do is rearrange it so that we have the x's and the y's together. So I'm going to take the x squared plus 4x and leave a little, and then we're going to have y squared minus 2y. And then I'm going to move that negative 4 over to the other side, make it positive, add 4 to both sides. Okay. All right. And then I need to figure out what I would have to add to each one of these to make them a perfect square trinomial. So remember, we take half the coefficient of the x term, the linear term. So half of 4 is going to be 2. And then we take whatever that number is and we square it to figure out what to add. So we're going to have to add 4 to make this a perfect square trinomial. Let's do the same thing here, taking half the coefficient. Come on, stream. Sorry about that, we keep cutting out. Whatever we do to one side, we have to do to the other. So we're going to add 4 and add 1 over here. All right. And then lastly, we're going to take these two perfect square trinomials that we just created and we're going to factor them. So x squared plus 4x plus 4 factors into x plus 2 squared. Remember, whatever number you got when you took half, that's how it's going to factor. So that's a nice trick when you have messy numbers. And then y squared minus 2y plus 1, well, that's going to factor into y minus 1 squared. And then on the right, of course, we need to add 4 and 4 and 1, we get 9. So from this, we can see that we're going to get our center and our radius. The center, again, would be the opposite of this number here. So x coordinate would be -2, y coordinate would be +1, and the radius would be the square root of 9, which is 3. And that's what we started with back up here, right? Okay. So that's how you go from the general form of a circle to the center radius form. And I just want to say hi to K.N. Cromwell. Yes, you will understand this when you are older. Okay. All right, so that's pretty much everything we needed to cover today, and I understand some of you might need to leave, so that's fine. I'm going to work one more example of converting from the general form of the equation of a circle to the center radius form and identifying the center and the radius, but if you need to log out, that's fine. Remember, a recorded version of this will be available in YouTube as well. Plus, you can access these notes in our link in D2L, along with all the rest of your class notes. Okay, so I'm gonna make a new page here. All right. Another example of converting general form to center radius. Okay. So let's start with the equation x squared plus y squared plus 6x plus 2y plus 6 equals 0. We can see that this is the general form of the equation of a circle. X squared plus y squared plus dx plus ey plus f equals 0. So you know it's going to be a circle, and we want to, now we're going to convert to center radius form. And the reason we often want to do that is so we can graph it. All right, so what's the first step? Step 1, you're going to get your x's together and y's together. Get x's together, y's together, and move the constant to the other side. So we're going to move the constant to the right, the 6. Okay, so we're going to have x squared plus 6x, leave a little space, plus y squared plus 2y, leave a little space, and equals, and we're going to subtract 6 over negative 6. Okay, now we need to figure out what we need to add to each part to make it a perfect square trinomial. We take half the coefficient of the x, the linear term. So half of 6 is going to be positive 3. 3 squared is going to be 9, so we're adding 9 here. Now we do the y's, so we take half of the 2, the coefficient of the linear term 2y. Half of 2 is 1, 1 squared is 1, so we're adding 1 to that guy. But whatever we do to one side, we have to do to the other, so I also have to add 9 and 1 on the right. Okay, so now we are going to have to factor each of these perfect square trinomials. And remember, whatever number you got when you took half, that's the number that you're going to use to factor. So x plus 3 squared plus y plus 1 squared equals, and now we have negative 6 plus 9 is 3 plus 1 is 4. So if I were to ask you what is the center, this is the center radius form, we're done. That's what I asked you to find. But if I were also to ask you to identify the center, you would look at the opposite of these two numbers. So the x coordinate of the center would be negative 3. The y coordinate of the center would be negative 1. And the radius, to identify the radius, you look at the square root of 4, which is 2. Okay? Now, in our D2L online classroom, look in the announcements. I've got some links. I'm going to be posting some links to both this video and some other circle videos that you might find helpful. And there are some announcements there as well about our first test. And just in general, check the announcements because there are opportunities for bonus points that can pop up and reminders of various assignments. So I hope you found this video helpful. If you did, please remember to give it a thumbs up and like it, so that helps other students to find the video. Thanks, guys, and have a great weekend.